Hello, everyone. Welcome back to the show. Show does not have a name except for the CircuitPython Library Showcase Show. I guess that's the name now. Okay, so as you know, I've been putting out a lot of libraries. Pretty much I've been taking my old project, PicoSynth Sandbox, and I've kind of been splitting it up into components and separating those components into separate libraries and trying to make those as good as they can be, so that eventually when we do finally finish the PicoSynth Sandbox synth, it's going to use parts of each library, which means that A, you can use these libraries one at a time, whichever one you'd like for your projects where they fit, or B, you could use a whole suite of tools. I just figured it was a better way to handle all this. Anyway, so the new library today is the Synth Voice Library. Yes, I need to come up with better names, but I can always rename them, and whatever. There's more important things. But let's go ahead and show this off. So we have Synth Voice. This library just pretty much Synth.io comes with a Note API, which is pretty powerful. It gives you a lot of options to handle things like pitch, whatever. And you really get in the weeds and build things up in filters, etc. Unfortunately, if you want to make your own voice, like a fully featured, monophonic synthesizer voice, I guess, with, filter, LFO, filter envelope, vibrato, all these other things, you kind of have to create each voice on your own. Anyway, this is just a shortcut. That's all this is. This is a shortcut to create a voice very quickly that has all the parameters that you're used to. If you're used to working with synthesizers, this should have most everything. Not everything. In fact, I just expanded it a little bit today with some new features, so there's room to grow here. But if I actually jump into the code here, if you can even see what I'm looking at here, you'll notice that this whole voice is pretty much a wrapped around encapsulated note object, right? And we're just controlling that using all the settings at our disposal in order to have full control of it, right? And I kind of, instead of having to go through here and control the note bend and the math operations, whatever, I've created these parameters that make it relatively easy to control components of a typical synthesizer. Attack level, attack time, bend range, etc., filter amounts, whatever. And it also handles some of the pressing and release states and some other stuff like that. In fact, this whole thing is building off of a bass voice class, which is, well, first of all, there are some actually cool tools I have in here. Some lerping, which is used for the glide parameters, an A and R envelope, whatever, attack and release envelope, that's used for the filter envelopes, which is pretty cool. You have some filter type constants. That's not really that important. But then the voice itself, so this is like the base object that's used for all other voice types that we have available. And it's, it handles stuff like, managing blocks and presses and release states, amplitudes, etc. Some basic stuff. Oh, and it handles velocity automatically, which is pretty cool. Like, you can control how much the velocity amount you want to adjust. All this is in the documentation. I will say, I wish the documentation was a little bit more concise. It's kind of hard to dip through here, especially how much everything inherits other things. It's kind of hard to find out exactly what's supported. I might update the documentation later. Now, we are not limited to just oscillators. In fact, we have a lot more than that. Probably the most exciting thing, really, is the sample voice. Now, there are ways to play samples directly. I think it's the Audio Core library. You can, play wave files, etc. And you can do some stuff with that. I think you can adjust the playback rate to change some of the pitches and so on. But you can't really do synthesis on those samples. You can't add a filter. You can't do, well, maybe you can do weird panning, I'm not sure. Vibratos, all this other like more advanced stuff that Synth.io does. Well, the synth voice, or the sample voice, what that does is pretty much gives you, in fact, you'll see here, it inherits that oscillator voice. So it gives you every single parameter inside the oscillator, except you can provide it with a full file, a path to a file, or you can just give it a large buffer for the waveform. And it'll automatically detect the pitch, and then it actually uses this weird function I made here, this FFT frequency, right? It runs a fast Fourier transform, and it tries to estimate I think you might be able to manually, like if you know the pitch of the note, if it's a piano note or whatever, you can tell it what pitch that sample is at. But if you don't do that, it'll automatically like kind of detect like, hey, what is the primary frequency at work here, and that's where it gets this FFT free thing from. It also does normalization on the sample automatically. That's kind of cool, just to make sure you're getting the full range of dynamics, I guess. Anyway, so that's really cool, and you can do looping too, and that's a really cool thing. So a few months ago, I added a pull request to CircuitPython to add waveform loop properties. Let me see. Synth.io. Waveform loop. Okay, here we go. Waveform loop start and end. So what it's doing is actually controlling these parameters and automatically adjusting the pitch based on your looping parameters. So that like if you have, let's say, a pluck, well, maybe pluck's a bad example, a piano, and the first like whatever of the piano, that first hit, you want to keep that, but you don't want to keep repeating ding ding ding. You want to just repeat the last half where it sustains out. You can set those loop parameters using a tuple. It's in the API. I'll show some of the code later. So it goes ding and it holds it out. Of course, you have to be a little careful with your loop settings, but you can get it pretty close. I'm not actually using the ring oscillator stuff yet. That's maybe something for us to add later. Anyway, so that's super cool, and I'll show how some of that works. And then the last section of this is the percussion stuff. Now, this is up to interpretation, but I pretty much made a percussive voice that makes it relatively easy to generate, kind of 808 sounding stuff, floor, kick, snare, hi-hat, toms, cymbals. I don't really have that much in the ways of cymbals right now, but it's pretty much just adjustments to the hi-hat, open hi-hat sound. Anyway, those are listed here. Like there's floor tom, high tom, mid tom. Now these are just presets. You can take, like for instance with toms, you can take the general tom class, whatever, and make your own toms using it. Same goes for the hats, which I think honestly this should probably be changed to cymbal. That actually make a lot more sense. Because it's kind of all the same. Maybe I'll make some more adjustments to make it more, hi-hat, closed, open, closed hi-hat, etc. But that's pretty cool. And this just makes it so you can make a really quick drum machine without having any samples at all. It generates them on the fly. Now, this doesn't have all the parameters. You can control filter and some other stuff like that. But it doesn't have all the parameters of the oscillator thing. I didn't feel like it was super necessary. So it saves you a little bit of processing power. Now, one thing I'll note, especially with the oscillator and sample stuff, there is a lot of processing power going on here. For my examples, in fact, let me just show off what I have. Here we go. We have a top-down webcam. It's not that great, but for my examples, I am using a Pico 2. This is the Pimoroni Pico Plus 2. It's kind of like just my dev board for now. And so this does, floating point calculations. I know Synth.io is very integer based, so I'm not sure how much floating point it actually does, but at least for the Python stuff, it will do some more floating point there, and that's nice. I'm also running into an I2S DAC here. It's the UDA1334. I believe this is the Adafruit board. They discontinued this a while back, but it's just an I2S DAC. It's pretty normal. My examples, I'm using PWM output in the example that are provided, but I just changed them so that we have a little bit higher quality. Everything's actually running at 48 kilohertz because I found that the Pico 2 can handle that pretty well. I'm not sure how high this DAC can go. Maybe I could go higher, but I figured that was good enough. In fact, I think I'm recording at 44.1, so it doesn't even matter. Anyway, let's jump into some of the examples. Now you can see what's going on here. Oh, and I have a keyboard here. This is using USB MIDI. I am patching it over. Let's show that right here using Pipewire graph or whatever. Oh God, you can't see it that well. We have this right here is the audio, this capture right here from the synth itself. I'm taking it stereo. In fact, I believe these examples are just doing mono, or, straight up in the center. I should add some panning. Maybe I'll show that in a second to show some of the stereo stuff you can do. What else am I doing here? Oh, and this one right here. Gosh, y'all probably can't see that much. Here you go. This is just the USB. I'm porting it over to the Pico Plus, and that means that I can get MIDI through. Let's go back. Well, I guess we'll stay on the screen cap because I have Thonny to show. Let's make this a little bigger. Should have prepared. 24. Yeah, it's big enough. Okay, so we're going to start with a simple test. These are all provided in the library for you to see there. This one's very simple. In fact, it's going to be annoying because it's like an alarm clock. It just plays a note every second. Default settings. The default settings of the oscillator is just a square wave. You know, pretty much basically what you get with the standard note API. Let's hear it. Okay, enough of that. And I didn't show this. Let me show it here in a second. You will see the LED goes on and off on board. You know, not a big deal. Very simple. That's not very exciting. You don't get much with that. But let's jump over to the next thing, which it's honestly kind of the same. It's just showing how you can interact with these voices. This is the MIDI example. And it's pretty much the exact same thing. We have the voice created here, which, by the way, on all these voices, you do have to provide the synthesizer object. The reason why is because it registers all the blocks, the block input devices with the synthesizer, as well as it handles all the press and release stuff automatically. It keeps a copy. I haven't created the destruct functions yet to remove everything from the synthesizer. I need to do that. And so you can dynamically reallocate stuff. Working on that. But you do have to provide it. It also gets the sample rate, which I believe is used. It's A for the sampler itself, the sample voice, as well as for some of the frequency settings for the filter. Cool. So this one, you just have a MIDI note. I'm going to play piano. It's going to play some really annoying notes. Here we go. Nothing exciting there at all. We'll move on from this. If anything, that's a good demonstration of just performance. You know, like that's fine. That was pretty good. Next example. I think this is the oscillator one. This is where it gets interesting. So we create our oscillator voice, and this is similar to the MIDI. The MIDI example is just adding more to it, right? We create our oscillator voice. We set our waveform. I'm using my synth waveform library. You don't have to. I think it does rely on it for the percussive sounds because I have to generate some of those waveforms. But if you don't use a percussive portion of this library, you don't actually need this library synth waveform. I recommended it because it makes it just really easy. In this case, like I'm doing a saw and then a saw, like a doubled up saw to kind of give it a second octave artificially. Just to make it a little bit more interesting. Plus, all these are monophonic, and there's no keyboard management in this at all, so you know, you got to get what you can. And honestly, playing it's a little weird because some of the release MIDI notes will like cancel out your presses, whatever. Obviously, if you're doing anything more complicated with this, you would I have my synth keyboard library put out recently. Check out the video, probably in the description below. I don't know. That's a good example of something that could help you manage these note presses better. Anyway, so then we have frequency related stuff. So this is where it gets fun. So we have a glide, right? So this is actually using that LERP, which is linear interpretation, something, whatever, to glide between the desired notes, right? Every time a note is pressed. This is in seconds, so we have half a second here of glide between each note. Great. Then we have coarse tune. This is in octaves, so we're going down an octave. Great. Then we have fine tune. This is in semitones or chromatic steps, right? So we're actually doing a fifth here. Now it's not gonna. This would be great if you had two oscillators going at the same time. You had the standard one and then one at a fifth. That'd sound awesome. This isn't exactly doing that. So it doesn't have much of a point. I'm just demonstrating. So honestly, if I play a C, it's gonna be 1, 2, 3, 4, 5. It's gonna be an F. Right? So it's not really that useful, but it's just a demonstration. Okay, then vibrato depth. Now, this, I believe, is an octave. So if I did a 1, it would be a full octave of vibrato. But instead we're doing 1/2, right? So it would be a semitone, right? And then the rate, this is just, in hertz, so 8 times a second. So we want to do a woo 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 kind of thing. You can make this slower, etc. And then we have, this is a new thing. I just added this morning, actually, because I was thinking about it. I was like, that's, because the percussive system uses something like this. I'm calling it pitch slew. There's probably a better term for it. If anyone knows what I should call this, please let me know. But pretty much when you hit that note, this in octaves, so like here it's going down 2 octaves. When you hit that note, let's say you hit a middle C, which is C4, I believe, it would start at C2, down 2 octaves, and then in the pitch slew time, which in this case is 0.2 seconds, it would take 0.2 seconds to go up from that C2 to middle C, the note you've actually pressed. Well, in this case, it is applying the tuning and stuff, so that's a different case altogether. So this creates some really cool stuff where it's like, boing, boing, that kind of stuff. Of course, you can go above, so it's bow, bow. Every time you play the note, you can do some cool stuff with that. It has a lot of, especially if you make it really fast, it has kind of a percussive sound to it. So that's new. That's most of the frequency stuff. Let's get into envelope. This is basic. This is just for the amplitude. This is ADSR, right? Attack level, the level it takes, that you reach. You can look this up in the synthio.envelope stuff too. The decay time to go down to the sustained level, and then once you let go of the note, the release time it takes to go back down to 0. Now, I believe you can have the attack level be below and then the decay time be, like the sustain level be above. I haven't fully tested that, but I think that's doable. Especially, you could do like a delay. You could say, hey, attack time be a second, and then attack level be 0, and then decay time be, a quarter second or something. And then have your sustain level 1. So maybe you like hit the note, and maybe one oscillator starts, and then another oscillator starts coming in after a second. I don't know, that'd be cool for some like multi-layer stuff. I might be wrong there. That might not be how it works. That's how it should work. But anyway, let's move on. Then we have amplitude, which is similar to envelope. Honestly, these could go together because this is the amplitude envelope, right? Anyway, your amplitude property here, this is just the overall level. Depending on how you have your output set up, like if you want to avoid clipping and stuff, it's kind of a good idea to drop it down a little bit. This is from 0 to 1, not a big deal. Then you have tremolo, right? This is pretty familiar. It's an LFO on your amplitude, right? Amplitude LFO, right? So in this case, we'll actually be going between 0.65 and 0.85 math, right? I believe it would clip at 1.0. I'm pretty sure it would clip. And at 0.0 as well. So depending on how you have your depth set up. And then your rate is in hertz, so twice a second. That's actually pretty fast, but for this, whatever. But it's only going up and down a little bit. Okay, now to the filter. Now filter's a little difficult because by default, SynthIO does not support block input on filters, on the note filter. Now, what block input is, if you're not familiar, is it's pretty much as the synth is updating in the background. It'll recalculate the block input every I don't know if it's every sample, but it's at least every couple of samples, so it's pretty accurate to the output of the audio. So when like all the pitch bending and stuff like that happens with block outputs, so you can't even notice, like you don't hear like jumps in those pitch bends because it's pretty on par with the sample rate. Now filters don't have that, and I understand why. It's because you have to calculate those filters every time you update them, and that takes processing power. So I think they chose that so that they didn't have to recalculate the filter constantly, which I'm sure would cause issues. So instead, all these properties, well, minus frequency and resonance, the like default ones. Also, there is a voice.filter type as well, so you can change between low pass, high pass, and band pass, and those settings are found at synthvoice.filter type.low pass, etc. You can look them up; they're not that bad. I'm just using low pass, which is the default here. But that's why down here, and I'm skipping forward, but when you look at the MIDI message processing, we also have voice.update. every time you call voice.update, it will update the filter settings. So if you're using async IO or something like that, you may want that to happen like every maybe 100th of a second or so. You have to play around with it to see what works best and provides you the best performance and sound. Because if it's too slow, you'll hear big jumps in the filter every time it updates. Anyway, so with that, filter frequency, filter resonance, pretty self-explanatory. These this is frequencies in hertz. Resonance is a Q factor thing. You'd have to look up the SynthIO filter stuff on the synthesizer object. Anyway, this is where the fun happens. This is for the envelope. This is the filter envelope here. We have attack, amount, release. I might adjust the naming of some of these. I didn't want them too wordy, but I might have to do like filter, envelope, attack time. It's a lot, but it might be good. Anyway, so this is that AR envelope that I was showing earlier. You have the amount of time it takes up to get to this filter amount level. Yes, I know it needs renaming. And then you have the release time to go back down to 0. In this case, 0 is this filter frequency value. So and the amount is in hertz as well. So after this attack time has elapsed, we'll go from 200 to 1400 hertz with the filter. And then we have an LFO here. Yes, in the future, I might add filter LFO rate. It would make more sense. I've been avoiding being too verbose. But filter rate, this is in hertz. So this is once every 2 seconds, 0.5 hertz. And depth, right? This is the depth of the LFO. Once again, this might be renamed. This is also in hertz. So these all interact together. So after this, filter envelope has, you're sustaining, right? You're at that sustain level. It'll be 1400 hertz. But then this envelope, this LFO will add to that. So like your max will be 2400 hertz and your minimum will be 400 hertz. Now, of course, it will, this LFO will be in effect before this envelope has really happened. There's no decay time to it, or attack time to the LFO. That might be cool, like a delay. That would be cool, but we don't have that right now. So right now I should add a delay. I think I can figure out how to do it, but whatever, we'll figure it out. So at the beginning, it might actually come out silent because you might have 200 hertz, and this filter depth might be adding to it, which will limit it to 0 hertz, which is pretty much no sound going through, right? Or maybe it limits it to 1. I don't know. So you have to be careful with your settings, just like you would on a modular synthesizer or a normal synthesizer. You can make bad sounds on it. Enough of that rambling. We've been through the voice. Let's hear what this sounds like. I got a lot going on. So there's tremolo, there's vibrato, there's filtering. You don't hear the tremolo that much because it's not too intense on this. But you hear that slew at the beginning. It's pretty fast. So like if we did like a second on there, let's change it. It's actually not that intense. Huh. Anyway, I'll have to play around with it, unless I might have not updated the library on this one. Let me double check. Whatever, we'll get back to it. Okay, so there's a bunch of cool stuff. You can create complex sounds. One thing I didn't show was panning. And I might add this to the example. Voice dot. Well, you can do pan. I think 0. Oh, it might be 0 is the default. And you go -1, +1. I don't know. Gosh, now I gotta look up the documentation because I don't remember. Pan depth, pan rate. Okay. Pan depth. Let's just go full out. And a lot of these LFOs, you can go negative, but in a case where you're just doing this, it doesn't really matter if you're negative or not. Maybe if you have 2 voices that are synced up in some way, it will matter. Rate, let's make it some random number. Let's hear that. So this should go fully through the stereo field. There's so much going on, I can't even really tell. I think it's working. Actually, is that pan setting correct? Yeah, it's correct. Let's take off. I feel like this filter LFO is doing a little too much. And also the vibrato's starting to throw me off. Let's listen to this now. You know what? I think I messed something up. I feel like the panning's not working, but you know why? I know why it's not working. It's because our synthesizer is probably not set up for 2 channels. Oh man, I was hoping not to edit this video, but I might have to at this rate. Yeah, channel count 1. That's why it's not working. Okay, let's update this. Now it should work. Oh, yeah. There we go. That's it. That's the sound. Okay. Cool. Now, we have more examples. I know, crazy. This next one is the sampler example. This is pretty cool. So what I'm doing is I'm loading a sample here, and we won't do the channel count. I have a test.wave file. This needs to be an absolute path from the virtual file directory, or VFS, right? So this is the root, and then the other thing. Whatever. Groovy. This is using the synth waveform library. So I lied before, actually. It's both the sample and percussive things do. The oscillator doesn't, I don't believe. So we're giving it synth object, given the file we want. You can load the file after the fact. You can do voice file equals test.wave. Or if you're loading the file through some other way, or maybe you have if you have a bunch of voices, like you're doing polyphony, right? You would want to do something like synth waveform dot from wave. You'd have to look up the docs, but I think this is how it works. And you'd get the data and sample rate, and then you'd have to do voice.waveform equals data, voice.sample rate equals sample rate. You'd have to do that to load it manually, but that works pretty well, and that way you could iterate through all your voices and give them the same thing, so you're not duplicating, your buffers and stuff, your RAM. Anyway. Lovely. We're also adding a release time here. Now, this is just an example. This is very simple, but you can do all the oscillator stuff to this. I mean, heck, you can do the same voice.pan depth equals, 1.0 voice.pan rate equals, here, we'll make it crazy. Yeah, you can still do everything there, as well as the filter envelopes, etc. If you do the filter envelopes, obviously you have to do a voice update. We actually are doing voice update here. The reason I'll show this in a little bit is there's a looping parameter. By default, the sample will just continue looping, right? But if you tell it not to by doing voice.looping, I believe this is in the constructor as well, it'll do a single shot. So play that sample one time. Actually, I don't think waveform will work in that situation. We have to check. But it'll play the sample one time and then cut it off. Until it releases. So I think the release time and some stuff will also come into effect here. We'll test that in a little bit. For now, let's work with this. Let's go. And this should be a piano. You can throw whatever waveform you want at it. In fact, this one's maybe not great because, I mean, it's 11,025 hertz sampling rate. Let's just hear it. Oh, you know what? Once again, I did the mistake of setting the panning, and then the synthesizer only has one channel. Here we go. Oh. So that's a little too much. So let's take that out, and let's turn the looping off and see what happens in this case. You know, I don't think it likes having the waveform loop. I think that throws it off. Let's turn those things off. Maybe there's a problem with that. I know it's in the constructor. This is a really short sample. You can give much longer samples. You'll notice the higher it is, the faster it is. Where the lower it is, the longer it is. This is not the most interesting sample. I'm so sorry. I should have put like a clap or something like. You could do anything, percussive, etc. Now, like I said, I mentioned this before. It will use the fast Fourier transform to determine what the frequency of that sample is. Of course, if you give it something more complicated like noise, a clap, whatever, it may get a weird number, so your pitches may be kind of strange, and that's where you might want to set them manually. I'll have to check on that parameter, see why it didn't affect that effect. But hey, that's it. Sampling. Sampling on CircuitPython Synth.io. And you can hear that loop. I don't have the settings set perfectly. If you really wanted it perfect, you have to find like the exact sample positions. If you took it out though, you'll notice the whole thing will loop, right? That's not really ideal, depending on what your sample is. So something to consider. That's very cool. There's a lot more you could do with that. Let's move on for now. Okay, last thing, and this is pretty cool. This is the kick, the drum machine, right? So we have a kick, snare, close hi-hat, open hi-hat, hi-tom, mid-tom, floor tom. And I'm just doing some basic stuff with the MIDI note number to pick out which voice to press and release, right? And you'll notice with these, you don't actually supply them the note number because they don't need it because they're percussive. There are some ways to change the frequencies of some of these, like the toms. You can adjust it dynamically. It would be cool to have an LFO on it. I haven't done that, but yeah, there's room for improvement here too. I think I found these from an example. It wasn't Toddbot, it was somebody else had done like a kick and snare and hi-hat example, and I kind of built up beyond that to create these cool sounds. Anyway, let's go. I'm really bad at playing drum machine on a keyboard. So the toms I just added last night. I think they're okay. They could use some improvement, but they're close. And these are single trigger, single shot. So you'll see here when I'm doing it, I'm releasing real quick, but it'll still play through until the note's over. So if you hold it down, it makes no difference, right? So pretty cool stuff. I think that pretty much wraps it up. If you're interested in utilizing this in your project, you'll have to look up the API. I know I did a bad job of showing off some of these things and some of the shortcomings of this library, honestly. At the moment, hopefully there'll be improvements in the near future as I work out some of these issues. Anyway, if you have any other questions, let me know. I'd be happy to answer them. Or if you need help implementing this in your project, let me know. I'm here to help. Or if you have any other ideas of more features to add, at this point, especially with the bass oscillator class, I kind of want to make it do everything. I mean, obviously you're going to run into some performance issues, especially when you have polyphony and stuff. But especially for monophonic uses, I think it'd be really powerful to just give you everything at your disposal, and then just adjust them with parameters and stuff, create presets, etc. Pretty cool stuff. Anyway, y'all have a great one, and until next time, catch you later. I guess I'm Relic. Well, my name's Cooper, but I go by Relic on YouTube and other places. Anyway, feel free to look at some of my older stuff. And like and subscribe the channel. Oh no, I didn't know my webcam was cutting out. Okay, anyway, see y'all later. Bye.